Hopefully you just finished going through 8.2. Remember, the sections in Chapter 8 we're doing all out of order. We did 8.1 and 2, now we're doing 8.5, and then we will go back to 8.3 before finishing up the unit with 8.4. Remember, at the end of 8.2, we talked about the fact that even though when you're in the rectangular coordinate system, there is just a single unique set of ordered pairs that give you each location on the graph. That's not the case in the polar coordinate system. In the polar coordinate system, there are literally an infinite number of possibilities as you rotate around. Consider the polar coordinate system, which is based on a point called the pole and a ray called the polar axis. The polar axis is usually drawn in the direction of the positive x-axis. So if you think about down here, this graph, if we think about our polar coordinate system, the pole is at the origin, and this would be the polar axis in the positive direction of the positive x-axis, and that polar axis can rotate in either direction about the pole, where the pole is that center point. Rectangular and polar coordinates, this is just a review of what you already know. You know that x equals r cosine theta because cosine theta is x over r. And you know that y is equal to r sine theta because sine theta is y over r. We know that the modulus was found using Pythagorean theorem. In this case, we've got r squared equals x squared plus y squared. And we know that we can find theta using tangent, which is y over x. If a point has rectangular coordinates x, y, then it will have polar coordinates r theta. So there's my rectangular coordinates, and there is a set of polar coordinates. But I could have an infinite number of different polar coordinates that correspond to the single set of values x, y in rectangular form. An example of r theta might be 350 degrees. And we're going to show you how to plot that on this polar graph. It says to plot each point by hand in the polar coordinate system and then determine the rectangular coordinates of each point. This is a set of polar coordinates for point P. Point P is at 135 degrees. We're going to find theta first and then go to r. That's the order you should always attack this in. You're going to find theta first, then go to r, whatever your r value is. So I'm going to locate theta. Theta is 135 degrees. 135 is in quadrant 2. Now I want you to notice that each of my quadrants is equally divided into 3 sections, so that would be 30, 60, 90. I do not have the 45s marked. So if I need 135 degrees, that's 90 plus 45. So that 135 degrees is going to be here. And then after I've located theta, pretend that's straight. Then I go to r. R is a positive 4. Positive 4 is 4 loops out. So from the pole, I count out 1, 2, 3, 4. That is where P falls. If, however, I was given negative 4, 135, because I find theta first, I would still find this as 135 degrees, but negative 4 would have me move in the opposite direction. So I would think about extending that line, that polar axis, all the way across, so that this is 135. If I would go to positive 4 here, if I went to negative 4, it would be 1, 2, 3, 4 back here. That's why we always find theta first. Okay, so we graphed it. That was our first thing we were told to do. The next thing we're told to do is find the rectangular set of coordinates. Well, my rectangular set of coordinates is x, y, where the polar coordinates are r theta. To find x and y, I use these 2 equations. X is r cosine theta, y is r sine theta. R is 4. Theta is 135 degrees. Plug in what you know. You know cosine and sine at 135. Cosine is a negative square root 2 over 2. and sine is a positive square root 2 over 2. So x, therefore, is a negative 2 square root 2, and y is a positive 2 square root 2. So my rectangular set of coordinates for point P is negative 2 square root 2, positive 2 square root 2. And I write it as an ordered pair. This is the only possibility for my rectangular coordinates for this point. But remember, I told you have an infinite number of possibilities for the polar coordinates for that point. I have 4 135. What else could I have? Well, I could go another rotation. 135 plus 360 is 495. So that is another set of polar coordinates that give me point P. I could subtract 360. 135 minus 360 would give me a negative 225 degrees. That's another set of polar coordinates for point P. Or I could do negative 45, negative 4. Negative 4, negative 45 degrees. Or I could do negative 4, positive 135 degrees, because that would be this angle, and then I move directionally a negative 4. Let's look at the next example. For B, we are plotting point Q. So let's plot point Q, and then we'll find the rectangular form of those coordinates. So Q is at 230 degrees. Remember, I'm going to find 30 degrees first. 30 degrees is going to be this first line that's marked from the polar axis. 2 is 2 units out on my circles. So that's point Q right there. That's Q. 230 degrees is just one form of the polar coordinates that point could have. I could go another rotation and have 390 degrees. I could go backwards a rotation and have negative 330 degrees. I could land at this other angle and have a negative 2. So I could have negative 2, and that would be 210. So that's just 3 other possible sets of polar coordinates that would give me Q. Now let's look and see what the single set of rectangular coordinates would be. Remember, there's only one option for rectangular coordinates. You have x equals r cosine theta and y equals r, sine theta. Well, r is 2 and theta is 30 degrees. So x is going to be 2 times square root 3 over 2, and y is going to be 2 times 1/2. My rectangular coordinates for that point are square root 3, 1. And if I think about graphing that, square root 3 is going to be, about 1.5-ish. And then so I go over further, then I go up 1. That makes sense. It would be right about there. Okay. Let's do R. Okay, now we're going to be being asked to graph one with a negative modulus, or a negative R value. So we find our angle first, 2 pi thirds. Where is 2 pi thirds? Well, 2 pi thirds is the same as 120 degrees. So I'm looking at this line right here, right? I'm looking at this line right here. So if I rotate in a positive direction, this represents 2 pi thirds. So if I went out 1, 2, 3, 4, this would be positive 4 2 pi thirds here in quadrant 2. Where is negative 4 2 pi thirds? Instead of quadrant 2, it's going to be in quadrant 4. So I travel in the opposite direction along this line that represents 2 pi thirds until I get to negative 4. 1, 2, 3, 4, right there. That is point R. Point R is the location negative 4 2 pi thirds. And I could again come up with a multitude of different polar coordinates that represent that same point on the polar axis. I only have one set of rectangular coordinates that represent that point. x equals negative 4 cosine 2 pi thirds, and y equals negative 4 sine of 2 pi thirds. So that's negative 4 times negative 1/2, and negative 4 times square root 3 over 2. So x is a positive 2 and y is a negative 2 square root 3. That puts us in quadrant 4. X is positive, y is negative. Okay, the last one on this page is another point Q, negative 3 pi 6. Well, pi 6 is this 30 degree, but we know we're going to have to go in a negative direction. So instead of quadrant 1, I'm going to have to pass back the other direction and end up in quadrant 3. Negative 3 is from the pole 1, 2, 3. But remember, we found pi 6 first. We found theta first, and then we traveled in a negative direction from the pole. So this is where point Q would be in quadrant 3. We were given negative 3 pi 6. I've written down a couple of other options. That's the same thing as a positive 3 7 pi 6 or a positive 3 negative 5 pi 6. Those are two other polar coordinates that get us to the same point. There's only one set of rectangular coordinates though for that location. Negative 3 cosine pi 6, and then y is negative 3 sine of pi 6. So my rectangular coordinates are negative 3 square root 3 over 2 and a negative 3 halves. Both are negative because I'm in quadrant 3. Let's look at a couple more examples. I actually want you to pause the video. I want you to plot R and S on this next page. Point R and point S, plot them, find the rectangular coordinates, and then restart the video and check and see how you did. Okay, here you go. I graphed my points on the polar coordinate and gave you an alternate set of ordered pairs polar coordinates for those 2 points. And then I also found the rectangular coordinates for R and S. If yours don't match, go ahead and check it out and see if you can figure out why. The last example that we worked through, we have four times to practice it, but it's what we've already been doing. This is not new. This is exactly what we've been doing. While a given point in the plane can only have one pair of rectangular coordinates, that same point can have an infinite number of pairs of polar coordinates. This is where this section formally introduces that concept. We've already been doing this. It says give 3 other pairs of polar coordinates for this point. P is at 5, negative 110 degrees. Well, I want us to go ahead and think about graphing that point just so that we can practice. You can draw your bullseye, those concentric circles of the polar graph if you want to. I'm just going to mark out where we would have, I need to go out 5, 1, 2, 3, 4, 5 units. 110, negative 110 degrees, where would that be? Well, negative 110 degrees is going to be 90 and then 20 more degrees. So it's going to be about right there. That's where my polar axis would rotate through at negative 110. And I'm going to go out 1, 2, 3, 4, 5 units. So that would be point P right there at 5, negative 110 degrees. Well, what else would point P be? If I extended this back that way, remember this was 20 degrees, right? So that's going to be 20 degrees. So that would be at 70 degrees. And then that would mean I would travel in a negative direction. So that could be a negative 5, 70. I could stick with positive 5. And I could add 360. So 360 plus 110 would put me at 5, 250 degrees. Or I could stick with that and subtract 360, which would put me at 5, negative 470 degrees. So I'm just going rotation-wise. And then I could rotate from there. I could do negative 5, 360 plus 70 is 430 degrees. And there's 4 instead of 3 other pairs of polar coordinates. So you can see how you can just go rotations either direction to find more pairs of polar coordinates. For this one, we're supposed to give 2 pairs of polar coordinates for that point with given rectangular coordinates. Well, when I start with rectangular coordinates, I first need to reproduce at least 1 pair of polar coordinates. Let's look at a graph. My graph is 6 and then negative 6 square root 3 for x, y, where x is my real part, y is my imaginary part. So x is going to be 6 here, y is going to be negative, so negative 6 square root 3. So I'm thinking about a vector that is down here, right? Try to make that more straight. So I'm thinking about graphing that vector where x is 6 and y is negative 6 square root 3. I need to find r and I need to find theta because that's what my polar coordinates are made up of, is r theta, polar coordinates right there. So if this is the vector, x is 6, y is negative 6 square root 3. R is the square root of the sum of those squares. Let's think about how we square this. When I square this, well, 6 squared is 36, that's easy. But when I square this, I do negative 6 times negative 6 is 36. And then square root 3 times itself is 3. So I have 36 times 3, which is 108, which is 144, and r is 12. Then to figure out theta, I use tangent. Tangent theta is y over x. This is what I messed up in my other video because I didn't stack it correctly. So we're going to make sure we do it right this time. Y is negative 6 square root 3 over 6 gives me a theta function value of negative square root 3. Well, what angle in quadrant 4 has a tangent value of negative square root 3? That angle is 300 degrees. You can look back at your unit circle and do some quick calculations to figure out tangent. So theta is 300 degrees. The most simple version of my polar coordinates then is going to be positive 12, positive 300 degrees. That's 1 pair of polar coordinates. Another pair of polar coordinates would be to subtract 360. I'd have 12, negative 60 degrees. Or I could rotate, I could think about what is that corresponding angle up here in quadrant 2, and then do a negative 12. That corresponding angle in quadrant 2 would be 120 degrees. So it would be negative 12, 120 degrees for another pair of polar coordinates. Okay, let's do our last couple of examples. Give 2 pair of polar coordinates for the point with those rectangular coordinates again. The first step is to sketch. So x is negative 1, y is 1. I'm moving into quadrant 2. That's where my vector is going to be. X is negative 1, y is 1. I need to know what r is. Square root of negative 1 squared plus 1 squared is square root 2. R is square root 2. Well, what angle in quadrant 2 is going to have a tangent function value of y over x is going to be negative 1. My angle in quadrant 2 that has a tangent function value of negative 1 is 135 degrees. So r and theta, that gives me my polar coordinate, r theta. So the most simple polar coordinate pair is going to be square root 2, 135 degrees. I can rotate from that either direction, or I could think about moving to this 45 down here, which would be negative 45, so I could do negative square root 2, negative 45 degrees. I could do positive square root 2, add 360 to get at 395 degrees. I could stick with this negative square root 2 version, but I could think of it as 315 degrees. All of those 4 pair of polar coordinates reflect this value right there. All right, last example. I encourage you to pause the video, work this one out, and then come back. Okay, on D, we were given a polar coordinate pair to start with. The polar coordinate pair 3, 140 degrees. I find 140 degrees first, and then I go out 3 circles, 3 units, so that's where R would be. If I add 360, I get to 500 degrees. If I want to think about what if R is negative? What if I used a -3? Well, I would need to see what this value would be. If I'm at 140 degrees here, that means I am 40 degrees away from the x-axis, which means this would need to be 40 degrees away from the x-axis. So that would be either a -40 or a positive 320 represented here. So if that's the angle theta I find, and then I move -3, those would be another pair, 2 pairs of polar coordinates.